Okay, well, today as promised, we will be working on chapter 4, reactions. Let's learn something new and let's go. Well, I appreciate the comments that you're giving me and how to improve my YouTube videos. One thing that I did not change, what you guys asked for, why not write problems or anything that you want to write while you're recording? I feel like that's time consuming for you, and we make the video longer for nothing. So we're gonna talk about two important subtopics today. One, type of connections or supports. Two, total number of equations. In two dimensions, we're going to focus on two dimensions. You have 1, 2, 3 types. Pinned or pivot looks like this, a triangle. Has 2 unknowns, ax and ay. 1, 2. You have roller or hinge, sometimes. You have one unknown perpendicular to the surface. So if this looks like this, rotated, so that will be rotated counterclockwise or clockwise 90 degree or pi over 2. That's your reaction in this case. And then you have fixed. AX, AY, moment at A. I hypothetically assume all of the connections having a letter A. Could be C for cantilever. That's sometimes called cantilever or wall connection. So, knowing your connections is definitely vital, crucial. So total number of equations, always fixed, you don't have to think about it. 2 force equations, and then 1 moment. And I intentionally put it that way to reduce some time for you, and hopefully you could memorize it or picture it like this. Number of equations or number of supports, type of supports, count how many of them, and number of equations or the total. Number of unknowns should, in AASHTO, American Association of State Highway Transportation Officials, should, shall means must equal number of equations. Otherwise, it's going to be statically indeterminate. You classify a system of equations, what is it like? Infinitely many solutions, no solutions, and specific solutions or unique solutions. Same thing here. Statically indeterminate, statically overdeterminate, statically underdeterminate. So, that's being said, let's get to the real game. Into the real game. Whoop. Pivot, roller, fixed, number of equations. Hopefully this chapter is going to be one only video, and we could obviously have more if needed, but it's not that hard. You have something like this, a beam. You're going to see me draw one line, that means a beam. Later on down the stretch we're going to talk about UDL and non-UDL, uniformly distributed load, or sometimes called EDL, evenly distributed load. Let's assume that we have 1 kips here, 2 kips here, 2 feet, 4 feet, 2 feet, and let's call this as A and B supports. So you could probably illustrate this, a beam, put your finger here, put another finger here, put 2 fingers support here, and let's see what would be the reaction at each end in order to make equilibrium, or the structurally safe, factor of safety, at least 1. Well, that's the problem statement. Required, we're going to be asking for reactions at A, comma B. And we're going to write the magic word, which is fun. And let's have fun with that. I draw AY, BY, but in reality it should be AY, AX. Why? This is what? Pin or pivot. This is, let's stick with the green here, BY, that's right, because it's a roller. So, sum of the forces in the X automatically is going to give you AX, nothing horizontally. You don't have any braking force, you don't have any wind load, snow load, seismic, whatever it may be. So your AX equals your. If you're going to be a bridge engineer, you need to have at least one of the connections, or sometimes we call it fixity, pin, because driving, braking force, ladder load needs to be accountable. So, let's sum the forces in the Y, which we call them dead load, or maybe if you're a bridge engineer, you're talking about HS20 type of truck configuration. It looks similar to this, except it needs one more, axle load, but it's much bigger, like 32.8, 72 kips, or 36 ton. I'm not gonna get into the details because I know most of you will say, let's first understand this and then we could talk about something advanced, which make total sense. So AY positive, -1, -2, -1, -2 plus BY equal 0. So AY plus BY equal 3 kips. You don't have to put the kips here. Please, this is the most important thing in statics, so you better understand this. The reaction. I am going to erase these 2 lines. And I'm going to go ahead and sum the moment. So if you want to call this step 2, let's say continued. Step 3, sum the moment at specific location, let's say A. Let me tell you something, just FYI. Typically we sum the moment at the most number of unknowns. Why? Well, we need to reduce number of unknowns. Summing the moment at A, that will take care of AY, B, AY, AX. So we'll be having just BY. In reality, for this problem, it doesn't really matter, because we don't have really x, it's 0. So we've got negative 1, 1 times 2, 1 times 2, don't forget, here's your a, here's your a, here's your 1, clockwise, minus, similar with the same thing, 2 times 4 plus 2, and plus by times 8. 0. So what is this? 2 times 6, right? 12, 14, 14 divided by 8, which is 7 divided by 4, and 7 divided by 4, if I'm not mistaken, it's 1.75 kips. Thus, your AY equal 3 minus that, so that's 1.25 kips. So your assumption is correct, and your values are as follows, which makes sense. This needs to be greater than this. By how much? Who knows? The calcs shows that it's about, what, like greater than by 30% maybe, or maybe 25, something like that. So that's because 2 kips here, and obviously you could figure out those values geometry just using similar triangles. That is pretty much it for chapter 4. It's not a hard chapter. I will be introducing UDL, but I will be introducing that in the next chapter, chapter 5. I typically include part of chapter 5 with chapter 4, but since the book is doing 4 separately and 5 separately, and it would be too much for you for the first test for my students. So we'll be talking about UDL, non-UDL, and all that crap, hopefully after the test. So that's pretty much it for this chapter. Please let me know if you have any questions, comment below, and we'll see you next class. Peace.